Okay, so this is when vectors kind of ties back into some of the things that we have done previously. And it's another time where we can look at drawing vectors geometrically in two different ways. So what we've been given, this is from the slide, we've got a ship that is sailing 30 miles at a bearing of north 22 degrees east. So we're going to draw our compass just like before, start north, go 22 degrees to the east, and we're going to draw a vector with a magnitude of 30. This right here is my 22 degree angle. I'm going to label that. Then we also have the current that is fighting the ship, or the ship is fighting the current, I should say. So it's going 15 miles at south 48 east. So we're going to go here. My vector is going to be about half as long. There's my 48. And we want to know the resultant magnitude and bearing. Well, this diagram, I know that somewhere in the middle is going to be the resultant, the actual path of the ship. Well, that's not really helping us, so we're going to draw it as the start of 1. So there's my 30. And we know that's 22 up here. And then where the first one stops, the second one starts. So I can take this vector, the current, and draw it where the ship stopped. I know it's not how it's actually working, but that's going to then create my resultant, which I need to find. I'm going to slide this up here. And I also know that the angle right here is 48 degrees. Using knowledge about triangles, I can find this angle to the left because alternate interior. So that's going to give me 22 plus 48. Tells me that if I had this triangle here, I'm looking for x. I know side lengths, and I know the angle between them is going to be 70 degrees. Think about what you know about triangles. How could you find that resultant right here, that x? And then how could we find the actual bearing or the angle that that ship is traveling at from north? So we could find that little angle inside the triangle and use that. One thing that you can think about, this dashed line, the resultant, is the actual path. If I have a ship that is traveling north 22 degrees east, and then I have that current going south 48 east, it's going to take that initial path and push it down. So the ship is going to be actually traveling a little bit less north and a little bit more east based on that current. And that's what this resultant is showing. It's taking the path of the ship and it's pushing it a little bit less of an extreme north angle, because that's what happens, is your current is going to move the actual boat. So you need to find x, think law of cosines, and then we need to find the angle to use it for the actual bearing.